You are welcome to session 2 of Unit 3. And in this session, we'll be looking at significant figures in measurement and computations. My name is Patrick Ej. Now, at the end of this session, you should be able to explain significant figures and how to report scientific results with the appropriate number of significant digits or figures, and also differentiate between accuracy and precision in measurement. So let's look at uncertainty in measurement. And whenever we talk about uncertainty in measurement, then we are talking about the accuracy as well as the preciseness of a measurement. And in physics, anytime we talk about accuracy or we talk about precision, then we are talking about the reliability of a measurement that has been made. And so as applied to measurement, the accuracy is expressed by stating the uncertainty of the numerical result. And what do you mean by stating uncertainty of numerical results? It talks about the estimated maximum amount by which the results that you have measured will differ from the true or the accepted value. So in other words, accuracy refers to how closely individual measurements agree with the correct or true value. So let's take, for instance, the voltage of a source, of a DC source, is, let's assume, to be 2.0 volts. Now, when you take a measurement using your voltmeter, and let's say you get 1.97 or 2.01, we can say that all these values are accurate because they are more close to the true value of 2.0 volts. So an example is that if we have a box that has been advertised to contain 15,000 nails, then we can assume that there are between 14,000 and 16,000 nails in that box. And so the uncertainty amounts to plus or minus 1 in the last significant figure. And so in our case, the last significant figure is 5. And so when we have minus 1, that will give us 4, and the plus 1 will give us the 6. And so we should have between 14,000 and 16,000 nails in the box that has been advertised. Now let's look at significant figures. And the accuracy of a physical measurement is properly indicated by the number of figures that are being used to express the numerical measure. And conventionally, only figures that are reasonably trustworthy are retained. And so those figures that are reasonably trustworthy and they are being retained in our measured values are the figures we call as significant. And in recording certain numbers, the location of the decimal point requires zeros to be added to the significant figures. So for instance, you measure the value and you have to record it to 2 decimal places, but then your instrument is giving you 12.1 centimeters or 12.1 volts, 12.1 amperes. Now to get your 2 decimal places, you will add 0 to get 12.10 volts. Now the 0 which has been added is only to indicate the number of decimal places, and in this case, that particular 0 is not significant. And so, like I said, these zeros only serve to locate the decimal point and are never considered to be significant. Now, so an example is the length of a page. And the length of a page has been measured to be 22.7 centimeters. And so here, we'll say that the length of the page is to 3 significant figures. Now, the thickness of a page, and this is recorded as 0.011 centimeters. And so here, this is it has been measured to 2 significant figures. The distance of the sun, which is 149,600,000 kilometers, is to 4 significant figures. And the speed of light, which is also 299,790 kilometers per second, is also to 5 significant figures. Now, when we mention the figures like this, it becomes very confusing. For instance, seeing the distance of the sun to be 149,600,000, and we are saying this is to only 4 significant figures. To have a clearer view of the number of significant figures, it is good to write or express the figures using the scientific notation or standard form. And this is able to give us the actual figures that are being considered as significant. numbers that will, so the non-zero, the first non-zero number becomes our first significant figure in that order. And so when we convert these our values, or we express them in scientific notation, so the length of the book or the page now becomes 2.27. And so here the first three digits are all non-zero. And so we have three significant figures. The thickness of a page will now be 1.1. And so we have only two non-zero digits. And the distance of the sun now becomes 1.496. So four non-zero digits. And all these digits are significant. And the speed of the light now becomes 2.9979. And all these five digits are non-zero, and hence they are said to be significant. Now, we must not confuse ourselves with the zeros. So we mentioned that the first non-zero number. What of instances where we have the zero within the number? So, like this example, the speed record for a bicycle is 80.13 miles per hour. And so here we have 8, and after 8 we have 0. And so if we are saying the non-zero, then are we saying that the 0 after the 8 is not significant? Good. So in this case, the 0 after the 8 is significant. It is very significant because here the 0 is not indicating the position of a decimal, but it is rather telling us that the number is 80 and not 79 or 81. And so the 0, which is embedded in a string of significant figures, can never be significant itself. And so we must always take note of that. So for instance, when we have 803, 705.12, now the 0 in between the 7 and the 5 is significant, which is telling us that the number is 705 points, the additional decimal places that we have. And so in this case, 80.13 is to four significant figures, or it is accurate to four significant figures. And so, like we said, we shouldn't be confused about having a zero in between a string of numbers. What are then the rules for computing significant figures? So there is always a pronounced and persistent tendency on the part of beginners to retain too many figures in a computation. And this not only involves too much work, but worse still, it will lead to fictitiously precise results. So when you are maintaining or retaining a lot of numbers, then know that you are increasing the workload on yourself whenever you are doing computation. And for that reason, the following rules are recommended, and it will save much of your time and also the time that you're going to spend in your calculation. And their careful use will also result in properly indicated accuracy. So rule number 1, in recording the result of a measurement or calculation, one and only one doubtful digit should be retained. When we talk about doubtful digit, we are talking about the number of decimal places. And so in the example given, we can see we have the first number to one decimal place, the second to two decimal places, the third to three decimal places, and we must maintain only one. It means we can maintain all, or we can write all of them to one decimal place, and that will be 24.2, which is having only one doubtful digit, and the remaining two numbers must all also follow. So the second one should now be 25.3, 27.6. And 2, in addition or subtraction, do not carry the result beyond the first column that contains a doubtful figure. So we have two numbers, like in this example, two numbers which are having different doubtful digits. So the first column over here contains 4, and the second one contains 2. And so in our addition, we must end on the column that contains the first doubtful digit. And so over here, when we add 23.646543 to 10.01, then our answer should be left in two decimal places, and that becomes 33.66. But you observe that the answer was 33.6643. And so we must now leave it to four significant figures, as we can see in the 10.01. Now in subtraction 2, we must do the same. And so here we have one number to one decimal place and another to three decimal place, and we must leave our answer to the number in one decimal place. And in our case, the answer now becomes 0.8. The next row is multiplication and division. And in this, we must carry the result to the same number of significant figures that there are in that term, which has the least number of significant figures. And so let's take this example. We are multiplying 3.95 by 9.1. Now, the least significant figure is 9.1, and so in our multiplication, we must leave our answer to this number of significant figures, that is two significant figures. And multiplying 3.95 by 9.1 will now give us 20.145. And so to two significant figures will now give us 20. And when we also divide, we must also do same. So in our division, we have 34.2 divided by 6.29934. And since we have the least significant figure being three significant figures, we must round our final answer to three significant figures, and that will give us 5.43. Now, in dropping figures that are not significant, the last figure retained should be unchanged if the following figures dropped are less than half the previous digit. In other words, if we want to drop and the last figure is 5 or greater than 5, then it is taken as 1 and added. But if it is less than 5, we drop it. So example, 24.5627. If we want to round this to four significant figures, then we can see that our fourth significant figure will end on the 6. But because the number after 6 is less than 5, we drop this value and our answer now becomes 24.56. Now, in 34.2523, if you are rounding this to three significant figures, then three significant figure will give us 34.2. But since the number after 2 is 5 or equal to 5, it is taken as 1 and added to the 2, which will make our answer now 34.3. And the same has been done in the remaining two examples. Now, students, in this session, we look at significant figures as well as the rules that are used in computing significant figures. Now, as we bring this session to an end, let us have this as a take-home. Round each of the following numbers to three significant figures. Students, I hope you enjoyed this session. Thank you for joining this session, and see you